Hello and welcome back to Electro Study. In this session, I am going to discuss important questions which can be expected for competitive examination like a GATE. The topic of discussion today is resonance. So it is one of the important topic in network analysis. First of all, I would like to show you the questions related to resonance for your information. Kindly go for a self-evaluation. So let me scroll down one by one. So all questions are based on the fundamental concept of resonance. So in the previous session, I have discussed about what do you mean by resonance and what are the important formula which you are supposed to remember for your competitive examination. Also, you can recall, it's a time to recall whatever you have learned in the last session. So the link is available in the description box and I button. Kindly go through that once and you can easily solve those questions. If you want, you can pause the video and recall the questions what is available. Don't take more than 10 minutes because maximum you can spend 1 minute for a question. Let me scroll back. I'm going to discuss the first question. So you can also start working out in parallel. Let's read out the question first. In a series resonance circuit, VC equal to 150 volt, VL equal to 150 volt, VR equal to 50 volt. So the source voltage is, let's consider an RLC circuit, RLC, correct? So you are providing a supply voltage. Okay. So you can mark like this. Let VS is a supply voltage. We have RLC series circuit. The voltage across resistor is VR and voltage across inductor, that is VL, and voltage across the capacitor is VC. According to the question, VL equal to VC. So that is equal to 150 volt. So you can apply the condition of resonance. So let's calculate the impedance. Impedance equal to square root of R square plus XL minus XC the whole square. Here you know that XL and XC will be equal to the same value. So Z is equal to the R. Okay. So we can able to say that it is very clear that the VL and VC, that is identical. So what is only the term which is remaining? So VR. So we can say that the source voltage will be identical to the voltage across resistor. Why? Because the voltage across inductor and capacitors are equal. Therefore, voltage across resistor will be equal to the total voltage which you are going to apply in the circuit. So let me know what is the value of voltage which you are getting across the resistor. That is already given in the question. That is 50 volt. So which would be the right answer? You can go for option A. Option A is the correct answer. Okay. Let's move on to question number 2. So you can read the question number 2. In an RLC series circuit, the voltage across capacitor and inductor are dash. So what is the right answer? So here it's a theoretical based question. You know that in case of RLC series circuit at the time of resonance condition, so we can say that the voltage across capacitor and inductor are 180 degree out of phase. So please select option A. Option A is the right answer. I think it's clear to everyone. Let's move on question number 3. So try to solve this question. Very simple only. What is the resonance frequency of the given specification? R equal to 10 ohm, L is equal to 0.1 Henry, and C equal to 10 microfarad. So what is the formula? Please recall the formula. The resonance frequency equal to 1 by 2 pi into square root of LC. So please substitute the value. You need to calculate the resonance frequency. So let's substitute 1 by 2 pi into square root of, what is L? 0.1 Henry. 0.1 Henry into 10 into 10 to the power minus 6 farad. So do simplify. So if you simplify, you will be getting 159.8. Like that, you will be getting the answer. That is approximately equal to 159 hertz. So you can do it very fastly. So let's move on to another important question. This question will be applicable for control systems also. If the root of an equation are real and unequal, then the response will be. So which is the right answer? If the root of the equations are real and unequal, the response will be overdamped. So you can go for option A. Here, in case of overdamped, the damping ratio theta will be greater than 1. Suppose if the roots of an equation are real and equal, then we call it as a critically damped system. For critically damped system, zeta equal to 1. Suppose if the roots, let us see the condition of, let us go for other condition. Roots are complex conjugate. So we call it as underdamped system. So these are the different cases. I think you can apply the condition for competitive examination. Okay. Now I would like to discuss question number 5. So everybody kindly go through the question number 5. A quality factor of RC series circuit is, the quality factor of RC series circuit is, so we will write Q is equal to 1 by C omega R. If the quality factor of RL circuit, so we will write Q is equal to 1 by L omega. Okay. So like that you can follow up. So for RL circuit, we can write Q is equal to, the right formula is Q is equal to L omega by R. This is for RL circuit. Okay, RL. So this is for RL circuit and this is for RC circuit. So tell me the right answer. Quality factor of RC series circuit, 1 by omega into C into R. So I'm going to select option number D. Option number D is the right answer. I think it's clear to all. Friends, now please read another question. In a sinusoidal response of RC circuit, the complementary function of the solution of I is equal to, for RC network, the right answer, I is equal to C into exponential minus T by RC. You can select the first option. So if it is for the inductive circuit, let us talk about the RL circuit. If it is RL circuit, we can calculate. So I is equal to C into e to the power minus T into R by L. So this is for the RL circuit. So you can proceed such kind of questions. You can see such kind of questions in the competitive examination. Now I would like to discuss question number 7. The circuit is said to be resonance if the current is dashed with respect to applied voltage. For a resonance circuit, we can write it as the supply voltage will be equal to the total voltage across the resistor. So the entire circuit will act as a pure resistive circuit. So what is the speciality of pure resistive circuit? The voltage and the current. If I talk, this is your voltage across the terminals, correct? And this is actually the current which is flowing through the circuit. Voltage and current are in the same phase. So there is no phase difference. Please select option A. I think it's clear to all. Now I would like to discuss question number 8. A 50 microfarad capacitor. So C is equal to 50 microfarad. That is equal to 50 into 10 to the power minus 6 farad. When connected in series with a coil having the resistance of 40 ohm. Let me write 40 ohm. And resonate at 1000 hertz. So resonance frequency equal to 1000 hertz. The inductance of the coil for the resonance circuit. So very easy question. FR equal to resonance frequency equal to 1 divided by 2 pi into square root of LC. So if you want to square it, FR square equal to 1 by 4 pi square into LC. So from this you can calculate L. L you can easily calculate by substituting the value of FR equal to 1000 and C is equal to 50 into 10 to the power minus 6 farad. Then definitely you can separate the value of L. So if you calculate properly, don't take more time. So you will be getting up to 0.5 millihenry. This will be the right answer. So kindly try once. If you are having any queries, please put up in the comment box. Let me know whether you are getting the answer or not. I'm going to discuss another question. A coil has designed for high quality factor performance, right? The voltage is rated at a specified frequency. If the frequency of the operation is increased 10 times and the coil is operated at the same rated voltage, the new value of Q factor and the active power P will be. So you already know that the quality factor, what is the relation between quality factor and the frequency? Quality factor is equal to the frequency divided by bandwidth. This formula I think you must have familiar. So in the first case, we'll write quality factor is directly proportional to the frequency. No issues. The second case, the quality factor, that will be directly proportional to 10 times of the frequency. Now, can you take the ratio between 1 and 2? So, of course, Q2 by Q1 is equal to 10F upon 10. Sorry, 10F upon F. So, here F and F got cancelled. Therefore, we will write the new quality factor is equal to 10 into Q1. So, therefore, what is the new value of quality factor? It is 10 times than that of previous quality factor. Therefore, explicitly I can put up the answer as Q increased 10 times. Without any doubt, I can select the option number D. Also, P decreases. It is inversely proportional. The active power that decreases 100 times. So anyway, option D is the right answer for this particular question. I think it is very clear to all. Let me discuss the last question of this particular session, the expression for bandwidth. So expression for bandwidth is equal to R divided by 2 pi L. So this point you are supposed to remember. So which would be the right answer? I would select option number B. So I think the answers are clear to everyone, and kindly practice similar kind of problem and keep on practicing. If you are having any queries, you can put up in the comment box. Also, if I want to do any particular video based on your suggestion, I'm going to do in the coming session. Thank you so much for watching this video. Happy learning.